Hi there, this is Max, and this is the Use After Free challenge. After going through the slides and video that talk about how Use After Free works, it's much nicer to interact with it and play around with it in order to get a better understanding of it. So, in this challenge, there is a Use After Free vulnerability, and the goal of the challenge is to get to the high score. There are 5 different options that you can play around with. There's a Malloc, a free, a use, a set, and a check to see if you got the high score button. Hint, these are all just Malloc and Heap Malloc and free operations on the hood though. The first option we can do is Malloc. This creates a chunk of size hex 20 and it stores a name and a score. That's it. The name is 12 bytes long and the score is 4 bytes for a total of 16. But of course, it has to allocate hex 20 because of sizing reasons. Then there's free. It frees the current player. That's it. It literally just calls free. That's all you have to do. Then there's the use. It creates a hex 20 size chunk, and then it plays the game. When it plays the game, it puts the value of 100 and 103 into this P array slot. It then generates random numbers in order to determine a score, and the maximum possible score is 100. However, if you look, you need to score at least 101 in order to get the high score. And this is hard. You can't actually beat this without causing memory corruption. And although you're not popping a shell like you probably want to, it still demonstrates this challenge fairly well. So my hint to you is to look at the Malloc and free operations, and there is a use after free vulnerability in here. If we switch to the challenge screen, we can look to see what this looks to run like. So we're going to modules, vuln classes, and exercise 1. And just like before, we have the source code that I was showing you. Because I just showed you the important things, I'm not going to actually do that. But we also have the start.py. In this case, we have a create, free, one, and play. But you actually don't really need to use these. You can actually solve this just by interacting with the challenge in the terminal. So we're going to do start.py, like we always do, but we need to go in tmux, of course. Now that'll work. Cool. So I'm going to do continue, and then I'm going to go into interactive mode. We can see here that we have a 1, and when we do a 1, we're creating a player. So I'm going to do Maxwell. Now if we go down here and look at the heap, we can see assorted chunks. This first one here, the 250, is actually the T-cache itself, so we can ignore that. The 20 is the first one we care about, and that's the player. If we do hex gx that, and we do like 4, we can actually see the chunk itself. We can see the size of it along with the previous use bit, and then we can see a string. If we do something like this, we can actually see the string here. That's pretty nice. So we can also just do this with a player. Yeah. If we just do p or print player, it also shows us what that looks like. So I think if we dereference it, it will also show us what it is. We can see that the player name is Maxwell and the score is 0. This only works because we have symbols in this program. However, in a lot of cases when you reverse engineering, you won't get access to that. So now, if we go back up to this screen, and we do use, the score is 91, and if we looked in the data structures, it would change. Now, if we do 2 for free, the player has been removed. And if we look in the bins, we can actually see this within the T-cache. That's cool. It has a chunk in the T-cache. That's awesome. I actually don't know why there's 2 things there. That's weird. Anyway, So we freed something that's in the T cache, but if you look at the player, the information is still there and it just looks janky and corrupted. That's kind of weird. I wonder why. So your goal here is to exploit the use after free vulnerability in order to get the high score in the program. Good luck.